Siti Roazlena Binti Mohamad Asnan, and my metric number is 202922. So for this assignment, me and my friends get a topic that we want to share, that is leptons. So in this video, we will discuss and explain more about what is leptons. So what are leptons? First, let me start with the basic ones. Matter is made up of atoms, and atoms are made of electrons and nuclei bound by the electromagnetic force. Electrons have a negative electric charge, and their mass is small in comparison to the nuclei. Nuclei are made up of protons and neutrons. In turn, protons and neutrons are made up of point-like particles called the up and down quarks. As far as we know, electrons are elementary particles, they appear to be point-like particles without internal structure. Next, the standard model of particle physics, which is strongly supported by extensive experimental results, suggests the material universe assumed to be built by a small number of fundamental particles, that is, quarks and leptons. So, quarks bind together through the strong interaction to make, for example, protons and neutrons. But leptons do not take part in the strong interaction and only interact via the electromagnetic and weak forces. So quarks, at least in normal circumstances, exist only in bounded state. But leptons, on the other hand, can be individually observed. Okay, now I will continue to tell about the type of leptons. We have experimental evidence for 6 different kinds of leptons. Three are negatively electrically charged and 3 electrically neutral. The best known electrically charged leptons are the electron, the muon, and the tau. The 3 electrically neutral leptons are neutrinos. Associated to each charged lepton, there are 3 distinct kinds of neutrinos. The first one is the electron neutrinos, the second one is the muon neutrino, and the third one is the tau neutrino. For each of these leptons, there is also an associated antiparticle which has the same mass and opposite charge. The electron is familiar to everyone. It is directly tied to the chemical properties of almost atoms. It is smallest charged particle we know, and is very stable. The electron antiparticle, the positron, is identical in mass but has positive charge. It was the first particle of the antimatter that was discovered. So now I will tell a little bit about the history of study about leptons. The first lepton to be identified which is electron. It was discovered by British physicist. It is J.J. Thomson and his colleague in 1897. Using a series of cathode ray tube experiments, the next discovery came during the 1930s, which would lead to the creation of a new classification for weakly interacting particles that were similar to the electrons. I think that's all from me. So now my next friends will tell more about leptons.
So, I want to explain about electron, muon, and tau. The electron is the lightest stable in subatomic particle known. The mass of electron is 0.511 mega electron volts. The lifetime of electron is infinity. So the second is the muon. The muon mass is 106 mega electron volts. The muon is about 207 times heavier than the electron. The muon in lepton is unstable, so it decays in about 2 microseconds. The tau with a mass of 1777 mega electron volts. The tau is about 3,500 times heavier than the electron. The tau length decays in 0.3 trillions.
Alright, now, so let's go to the another type of lepton. Okay, the other type of lepton is neutrinos. There are three types of neutrinos, or scientists call flavors. First, electron neutrino, muon neutrino, and lastly, tau neutrino. Neutrino has no electrical charge, which means they have a charge of 0 and have the size of 1 million times smaller than the size of an electron and 6 million times lighter than the mass of an electron. They are everywhere, but you will never see one. In fact, trillions of them are flying through you right this second, but you can't feel them. Neutrinos fly easily through matter and unaffected by magnetic fields. That means they can travel through universe in a straight line for millions or even billions of years. Due to the charge and the size, neutrinos are hardly ever interacting with anything except gravity and nuclear decay. Because they have a very little interaction with matter, they are incredibly difficult to detect. In fact, detecting a neutrino is kind of trying to catch a bullet with a butterfly net. One way to detect neutrino is to put a huge volume of huge transparent material in their path and wait for a neutrino to reveal itself by colliding with the nucleus of an atom, which will shooting off sparks of charged subatomic particles. The field of neutrino detection is having a major movement. Physicists are constructing ambitious experiments in exotic environments to up our odds of catching them. Scientists have to build a massive detector the size of an Olympic pool just to catch them. Some of well-known neutrino detectors, they are Ice Cube, which known as the largest neutrino telescope located in South Pole. Next, Super Kamiokande in Japan, a detector with 50,000 tons of ultra-pure water sitting underneath a mountain snow. Snow Lab, located in active nickel mine in Canada. And finally, KM3net, which is located at the bottom of the Mediterranean Sea. And the latest neutrino detector is Dune Experiment, located in South Dakota, the Deep Underground Neutrino Experiment. So why are we spend billions of money to build massive lab just to study neutrinos? Okay, scientists believe that neutrino could solve some of the biggest mysteries in our universe. For example, scientists believe that neutrino is a culprit behind asymmetry of amount of matter and antimatter. And if all goes according to plan, this mega science experiment could answer some of the deepest questions in the cosmos, including why we are all here. Really interesting, right? Okay, so where do they come from? Pretty much everywhere. They are produced in your body from radioactive decay of potassium. Cosmic rays hitting atoms in Earth's atmosphere create showers of them, and they are produced by nuclear reaction inside the sun and also by radioactive decay inside the earth, and lastly we also could create them in particle accelerator. Neutrinos have been called by so many nicknames such as ghost particles and even the vampire of physics. This is because neutrinos have a weird characteristic like no other particles had. Okay. Neutrino often referred as ghost particle because you cannot see them, you cannot see the neutrino itself, but you can see them knocking stuff around if you arrange things properly. Something like the detector. Other than that, neutrinos are identity agnostic. Neutrinos have different identities depending on whether they are interacting with other or traveling freely. And on top of that, their identities can change over time. This phenomenon is called neutrino oscillation. Other particles like electron will remain its identity whether they are interacting with other particles or traveling freely. No matter the situation, electron is still electron. But for neutrino, okay, here come the neutrino oscillation. For neutrino will change their identities over time depending on situation. For example, electron neutrino might become the muon neutrino, and then if you wait longer, it may turn back to electron neutrino. This behavior is unique among subatomic particles. Alright guys, so that's all from us. I hope you find our video interesting. Thank you guys. That's all.